I hope that you like my cheesy attempt at some math humor today up there on the board with the gang sign. He's just drawing his sine function, which is kind of funny and silly all at the same time. So what we're going to work on in today's session are the first two sections of Unit 2, which is 2.1 and 2.2. So we're going to talk about how you actually graph sine and cosine, and then we'll move into how you graph other functions. We're going to talk about the period length as well as domain and range today. So even if you think that you have them down pat, it's always good to go over it with the teacher, and then you can ask me any questions that you might have. So just a quick recap of what you should have learned at the end of last week. Oh, I guess we'll start with our essential question. This will be up again at the end of the session for week 5, so don't feel like you have to write it down this moment unless you just want to. My question is, what are some of the characteristics of the sinusoidal graphs for sine and cosine? So by the end of the session, you should be able to answer that question, meaning you could tell me about their domain and range, you could tell me about their period length, all of those things would be characteristics of their graph. And that's what we'll be talking about in today's session. So let me pause for just a second in case anybody would like to write it down now. But again, this will be up again at the very end of the session as well. Could you guys give me a green check mark when you're ready to move on? That way I know who's ready, who's not ready. That would be great. All right, Stefan, are you in the room as well? Just checking. Okay, so let's move forward. Here's a couple facts to remember that you should have learned last week, and we will be going over this in today's session. Only your trig functions are considered to be sinusoidal. So our trig functions would be sine, cosine, tangent, cosecant, you know, all 6 of them. Then, only sine and cosine have a domain of real numbers. We'll be talking about that later today in the session. We'll be graphing them and then coming back to this. But only those 2 specific ones. So only sine and only cosine have a domain of all real numbers. Remember that your domain is your x values. So that means sine and cosine could be any x value you can think of. Whereas tangent and some of your other ones do not have all real numbers. There's going to be places in the graph where we have some undefined areas. So we'll graph that later in this session. And then lastly, you should have learned last week, at the end of the week, that even functions are symmetric around the y-axis. So I'll be showing that to you today as well. So here's a couple examples of sinusoidal scenarios in real life. Hands moving around the clock, a CD spinning around in a CD player, and a pendulum that swings back and forth. So it's anything that has a constant motion and has the same motion, so a repeated motion over and over and over again. That would be a sinusoidal scenario. So let's try by starting to graph sine. So we're going to start with graphing sine. So everybody go ahead and make a coordinate plane, but this time instead of doing like 1, 2, 3, we're not going to graph ours that way. When we're graphing on the unit circle, we are going to start at 0, but then we're going to go around using our radian mode. So meaning we're going to have a pi over 6. The next spot on our unit circle is a pi over 4. We're going to have a pi over 3. Then we'll have our pi halves, which is right in the middle. I'm going to skip some. So after pi over 2, I'm going to skip some and I'm going to go over to pi. So I'm going to start with those, and then we're going to talk about how we graph these things. There are really 5 essential points when we graph. We need to graph all the zeros and the max and the minimum. These 5 points are actually going to give us our one full period of the graph. Now what a period is it's at the point where the graph starts repeating itself. So you're going to see after we graph it that makes a little bit more sense. So the first thing I want us to remember is that sine is always talking about our y values. So whenever I'm graphing sine, your sine of any angle is always your y value. Everybody okay with that? Sine's always your y value. Because remember, here's our unit circle. Just a quick little recap here. If I'm finding sine, sine is always opposite over hypotenuse. And your opposite is your height. So that's why sine is always your y value. Because sine's opposite over hypotenuse, and your opposite is always your y, how much up and down it is. So far, are you guys with me? Can I get a smiley face if everybody's on the same page so far? Okay, excellent. So when I come back to my unit circle and I'm graphing sine, I really only care about my y values. So let's come back here. Let me grab my highlighter. I would always keep a copy of your unit circle printed out this unit. It's going to be very, very helpful for you. So when I'm at 0, my y value is 0. Did you guys see the two things I highlighted? So when I'm at 0, my y value is 0. So let's go back to the graph. When I'm at 0, my y value is 0. So I have 1 point on my graph so far. Let's go back and take a look at the unit circle. Grab my highlighter. At pi over 6, my y value is 1/2. So let's go back to my graph. At pi over 6, my y value is 1/2. Let's make this out of 1. So at pi over 6, my graph is at 1/2. Let's go back to our unit circle again. At pi over 4, my y value is √2 over 2. So let's figure out what √2 over 2 is approximately on our calculator. So √2 divided by 2 is 0.7 or 0.71. So let's go back to our graph. Oops, wrong direction. So at pi over 4, it's 0.71. Maybe somewhere around in here. Are you guys still with me in how I'm figuring out sine? Yes, no, maybe so. We're always using our unit circle, and we're looking at our y values. So let's go back. So next on my graph is I'm looking at pi over 3, and at pi over 3, I get √3 over 2. So if I work out what is √3 divided by 2, I get 0.86. So let's go back to the graph. So here's going to be my coordinate, right? So at pi over 3, I'm at 0.866. 0.866. I'm almost there. At pi over 2, my y value is 1. So at pi halves, my y value is a 1. Now what you're going to see, if you keep going around your unit circle like this, you're going to see that your graph is going to go up, and then it's going to have matching points on the other side, and your graph is going to come back down. It's going to go dot, 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 just like we did over here. They're going to match exactly. And what's going to happen is if you keep on going around your unit circle all the way to 2 pi, it's going to be matching on the other direction. They're going to match. So our 5 points on our graph are essential points because I know that in the first lesson it actually had you plot each and every point, sort of like what we did together today. But then at the end of the session it said you really only need 5 essential points to graph. You need your zeros. So our zeros are going to be where it crosses our y-axis. There's 3 spots. Well, 1, 2, 3. Yeah, there's 3 spots on your unit circle where your y is 0. Let me grab my pointer. Your y is 0 when we're at 0. Your y is 0 when we're at pi. And then our y is 0 all the way back here at 2 pi. So at 2 pi, our y is also 0. So we've come full circle at that point. So I have 1, 2, 3 zeros. And then we need to find our max and our min. So your max is where it's going to be your highest point, which will be when our y value is a 1. And our lowest point is going to be down here when our y value is a -1. So those are considered your 5 essential points. Are there any questions so far up to this stage? It's all about your unit circle. Just keep your unit circle handy, and if we're talking sine, you're looking at your y's. So let's talk about the period for just a second. When I'm looking at my graph and I ask you, what's the period of this graph? A period is where your graph starts to repeat itself. So if I were to draw more of this graph, it would continue to go up and down, up and down, up and down, up and down. So a period is between one cycle and the next cycle. So let me draw in some lines. So that would be starting right here to right here. So this graph is considered to have a period of 2 pi. Because it does not repeat until here would be one full cycle, and then it would start to repeat itself again. Now domain and range are your x and your y values. So domain are what x values this graph could be. So this graph can go all the way left, this graph can go all the way right, so it said that it has all real values. So let's add this in. So my domain, x could be all real values. Or you could say all reals, either way. Now your range is a little bit different, right? Range are our y values. So as I'm looking on this graph, this graph maintains itself between 2 very specific points. Can you guys tell me what those points are? It certainly goes up and down, but it has a restriction, right? It doesn't just keep going up and up and up, and it doesn't just keep going down, down, and down. It's between 2 very specific points. You guys are right. It's in between 1 and -1. But here's my question. Are we going to include 1 and -1 as part of the range, or do I exclude them? Meaning, I can write my range 2 ways. Either you're going to write it like this, or we write it like this. If we remember back from Algebra 2, when we use a parenthesis, it does not include that point. When we use this bracket, it does include the point. So what we have to ask ourselves is, does this point lie right on 1? If it does, then I need to include it. So let's go back to pi halves for a second. At pi over 2, my y value is a 1. It's exactly 1, meaning it is included. So I need to write my range like it is down here on the bottom. It is included as part of the range. So let me pause for a second. Do you guys have questions? Or can you type in how you're feeling? Feeling good? Feeling like you need more practice? You know, kind of where are you at? Okay, great. You know, once I started highlighting my unit circle, it made a lot more sense to me about how to graph sine and cosine because, you know, the online lesson, it doesn't show you highlighting your unit circle, but really, if you just do that, then it gives you the points to plot on your graph and it makes more sense. So yep, so just recapping about the range, you're right, we do not include the one with the parenthesis. That's not the right answer. It's just this one right here. It would be the one with the brackets. Okay, I think that answers your question, right, Dakota? What do you mean? So this one right here means it's included. It's that really straight brace. That one. This, when you use this bracket, this means it is included. Parenthesis means not included. So you have to use the bracket. Okay, sorry if I misspoke earlier. Have to use the bracket. Bracket means included. Okay, so period we said is just how often it repeats. So if I give you a graph and it looks like, I don't know, do-do-do, do-do-do, do-do-do. The period would be the range between where it repeats itself. So maybe from here to here would be a period. There to there would be a period. So each of my lines kind of represents a period. So I don't think that concept is too tough to understand. So period is just where it repeats. And if you have a graph that goes up and down beside the graph, it would have to be from one starting point to the other starting point to where it would repeat. That would be a period. Domain and range we already went over, but in your notes if you want to, just reiterate to yourself, domain are your x values and range are your y values. So let's do a recap of how you guys think sine would be different. If we already graphed sine, how would cosine be different? Can you guys type that in for me real fast? What do you guys think? How would cosine be different than our sine graph? So the graphs kind of look opposite of each other. I'm a little weary of using the word opposite because in math opposite means negative, so we'll talk about that in a minute. The main thing I wanted you guys to take away is if sine talks about the y values, cosine is where we're looking at the x values. So let's take a quick peek at the graph. So here's our graph of sine. Remember we said at 0 it was 0, at 2 pi it was 0. Now cosine is different. So here's our graph of cosine. So what this one is telling us is that at 0 it has a value of 1. Now why would that be true? Let's go back and look at the unit circle real fast and just make sure we're all on the same page before we go over these summaries at the bottom. So let's go back to our unit circle. Unit circle, here we go. Let me erase my unit circle. Okay, so we said unit circle. If I'm talking about cosine, I'm talking about my x value. So at 0, it would be a 1. That would be a coordinate on my graph. At pi over 2, it would be a 0. At pi, it would be a negative 1. And those would be some of the coordinates on my graph. So let's check out their summary and make sure it makes sense to us. So at 0, they had 1, which is excellent. At 2 pi, they also had 1. At pi, they had negative 1. So yes, it makes perfect sense. So sine and cosine, they're sort of like opposites of each other, but they're really just shifted. They're really just shifted. So our sine starts at 0. Our cosine starts at 1. That's the main difference. What can you guys tell me about the domain of sine and cosine? What do you guys think? If I said, what's the domain of sine, what's the domain of cosine, what would you guys say? Excellent answers. Hi Carlina, you're joining us 20 minutes late, so you're going to have to watch the beginning of the recording. So the domains of both of them are all real numbers, which is excellent. What if I ask you the period of both of them? So let's check out sine for a second. Where does sine repeat itself? Okay, so I highlighted one full cycle, right? One up and down swing. So this has a period of 2 pi. What about cosine? Where is one full up and down swing? Exactly, you guys, excellent answers. So one full up and down swing is still at 2 pi. That's where it would start repeating itself. It still repeats itself on the 2 pi. Good job. So we talked about the range is going to be -1 to 1 on both of them, using that closed bracket because that means included. Both of them are still the same. And we said earlier in the session that both cosine and sine are going to have symmetry around the y-axis, right? Meaning here's your Here's your y-axis. It's the same on the right as it is on the left. Okay, good job, guys. Any questions about sine and cosine? We're going to jump into tangent. Tangent is a little bit more work. So we're going to graph tangent now. Tangent, we know, is the same as y over x. Everybody okay with that one? Tangent is the same as y over x. So let's make our graph here. Okay, so let's label a couple things. We're going to start at 0. Then let's go pi over 6. Let's go pi over 4. Let's go pi over 3. And pi over 2. And then I also want to try out pi. And I want to try out 2 pi. So I'm obviously missing quite a few points in there, but the idea is just for you guys to get a big picture of what's really going on. So let's start off with our first coordinate here. So let's start off at 0. At 0, I'm supposed to do y over x. Well, y over x, what would 0 over 1 be? 0 divided by anything? Oh, when 0's on top. Yes, 0 divided by anything is just 0. So that one actually has a coordinate. This one's not undefined. This one is just 0. Because 0 divided by 1 is just 0. It's undefined when 0 is on the bottom. And we'll get to one of those in just a minute. So is everybody okay with my first coordinate? Okay, great. So at 0, I had to do y divided by x. 0 divided by 1. Let's try my next coordinate, which is pi over 6. So at pi over 6, I need to figure out what's y divided by x. So let's try that out. I'm going to have a lot of squiggly room up here. Okay, so I did y divided by x. So let's work this out. 1/2 times, remember when it's a division problem, what we do at the bottom fraction is we flip it upside down and it becomes a multiply. So this gives me 1 over root 3. Let's work that out in decimal forms. That way I know where to graph this thing. 1 divided by square root of 3 is 0.577 approximately. So let me just put a 1 on the graph. And what we're going to learn is that tangent functions are not restricted to stop at 1. Tangent functions are going to look different than our sine and cosine. So at pi over 6, I'm going to get 0.57. So a little more than halfway. Can I get a smiley face if you are okay with that point on the graph? With how we found it? 1/2 divided by root 3 over 2. Excellent. So let's try pi over 4. So yes, tangent is much more work, I know. So we're going to do y divided by x. Well, when it's one thing divided by itself, what's our answer going to be? Like if I said 4 divided by 4, what would our answer be? Forget that there are these crazy radicals, right? If I just said 4 divided by 4, you're going to get 1, exactly. So root 2 over 2 divided by root 2 over 2, we're going to get 1. So at pi over 4, we're going to get 1. Let's work on pi over 3 now. So pi over 3, I'm going to make myself some space up here at the top. Pi over 3, I have to do root 3 over 2 divided by 1/2. Root 3 over 2 divided by 1/2. Which means I'm going to be multiplying. So my 2's are going to cancel, so I'm going to get root 3. If I work out what root 3 is, root 3 gives me 1.7 approximately. So on my graph at pi over 3, I'm going to get 1.7. We're doing awesome. We're almost there. Now let's try pi over 2. At pi over 2, I'm going to get 1 divided by 0. What's it going to be at pi over 2? What is 1 divided by 0, you guys? Ooh, it's undefined. You guys are right, undefined. that means that's going to be a spot on my graph where it's not going to cross. Dot, 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 dot. So when I get a 0 in for my x, that's when it's going to be undefined. Looking on my unit circle, is there going to be one more spot where my graph is undefined? What do you guys think? Where's my other spot going to be where my graph is undefined? Is there any other spots where my x is a 0? You're right. You're right, you're right, you're right. Down here, at 0, -1, that's undefined. So at 3 pi over 2, I'm going to get a 0 on the bottom if I try that because my y is on the bottom. Y over x. So I did get a 0 on the denominator at 3 pi over 2. So if I plug that back in, 3 pi over 2, that's also going to be undefined right there. Dot, 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 dot. So what we're going to find with tangent functions is if I continued on and I plotted all the rest of my points, we are going to get this funky looking curve where our undefined spots are really asymptotes. Anyway, forgive my horrible drawing. I cannot draw a straight line to save my life. I'm going to show you a better picture of tangent on the next page. But basically, once you keep plotting points, point, 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 you're going to see that it's going to get this crazy shape to your graph, and it's going to look like this. So there's a much neater version of what we were just graphing. So tangent, let's talk about domain and range for a second. And the period. So the period is going to be the spot before it repeats itself. So this particular graph has an asymptote, meaning an undefined area, and another undefined area. So as I go from left to right, this would be considered one period. So how am I going to write this period though? What do you guys think? This graph goes from negative pi over 2 to positive pi over 2. How much of a span is that? What's the period going to be on this? Negative pi over 2 to a positive pi over 2. That's excellent. It's 1 pi. You guys are right. It's pi. The way that you find distance, remember, is you can take one coordinate and subtract the other coordinate. What's pi over 2 minus negative pi over 2? 2 pi over 2, which is pi. So that's just the way you can find distance. If you're not able to figure out 1 pi in your head, you're just subtracting the two distances. So my period on this one's pi. What about domain? So let's talk domain. X values. Does this have all kinds of x values, left to right? Or are there spots where it does not have an x value? Yep, so your domain, good job. I like the way that Dakota wrote that in the chat area. So your domain is your all real numbers except any multiples of pi over 2. Do you guys see that? Pi over 2, 3 pi over 2, negative pi over 2. So he's right. The text this week, so you guys are going to get there tomorrow, and on Friday you guys are going to be learning about how to properly write domain. But for now, I think that we can see from the graph it is all real numbers except these multiples of pi over 2. So we can say all reals except multiples of pi over 2. And again, the text will go over exactly how you guys should be writing that. I was going to double check today before our session, and of course it wouldn't let me in to see how they write it on a test. So you guys are just going to have to check your online lesson to double check, so that way you know the proper mathematical formal way to write that. But let's talk range now. What about your y values? This time, are there restrictions at the top and the bottom, or is it going to keep on going forever and ever? What do you guys think? Excellent. So your range is just all reals. because these are going to keep on going up, 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 and down, 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 down. There's no restriction on range this time. So that's kind of the big ideas for today. Was cosine and sine do have a range restriction. We learned it's 1 to -1. Tangent is not going to have domain restrictions because it's going to go up and down, but it does have asymptotes, so it does have domain restrictions. So some have domain restrictions, some have range restrictions. So if you want to add that to your notes, you can sort of start making a little chart about what we know about sine, cosine, and tangent. So sine, cosine, tangent. This would be a great little chart to make and to add to your notes. We want to know what is the period of each one, what is the domain, what is the range, and what does the graph look like. So by the end of today's session, you should be able to fill all that in. The period for each one, the domain, the range, and a quick sketch of their graph. You're going to get into the cotangent and the cosecant graphs, and all that is coming next week. So let me remind you of what our essential question was for today. It is, what are some of the characteristics of the sinusoidal graphs for sine and cosine? So this will go under week 5. And again, pretty much all you're telling me is, what does the graph look like? You could talk about domain and range. You know, any of those things are considered characteristics. So thanks, guys. I hope that this was helpful and we covered 2.1 and 2.2. I pretty much see you right away next week because there's no school Friday, there's no school Monday. So in just a couple days, we'll be right back here to go over 2.3. So thanks, have a fabulous day, and let me know if you have any questions and I will stick around.